Okay, so now that you found your feature of interest, we're going to move down to the Snap tab. So this is where you'll have the autosave turned on all the time. And we're going to look at acquiring high resolution images and applying motion correction to those images. Go to seconds. Let's do like a 1 second acquisition. So you can change around between if you want to think in terms of frames, knowing that you're at 25 frames per second, or if you want to think in terms of seconds. And for acquiring, it's nice to just think in terms of seconds because. And actually, what I'll do is I'll go for 30. And then I can show you how the movie and final works. And so what that does, movie is going to save all 30 frames. Final is going to save the sum of the 30 frames. So take a look at that. Okay, and we can check out the FFT of that. And again, collapse metadata. Click on this. Click on your ring tool, and see what your spacing is. So what your real space FFT spot corresponds to. It's quite cool. Yeah, you can also zoom in if you want. Actually see. There's our lattice images. So the nice thing about being at 4K is you really do have quite a lot of pixels. So we could do 8K here. So we're only at, where are we? We're at 87,000 x, and yeah, you can see the quality of the images. It's quite nice. I'll try to tap the sample, move it a little bit. I'll acquire for 1 second, and we'll have a look at what each frame looks like. Motion corrected. Cool. So there you can see the motion correction working. So I did a little bit too much, but you can at least see it's a lot better with motion correction than without. So there's the non-motion corrected image, and then with motion correction, you recover at least some of the information. You'll see that each frame has almost no signal in it. So we're at 0.04 electrons per pixel in each frame, which is what we need for counting. But then if we take a 1 second acquisition, roughly 1 second, you'll see that the actual image you get is still very nice because we're applying that counting algorithm to each frame and then summing all the frames together to get this image. And so we did a 1 second acquisition, so we have 5.9, so roughly 6 electrons in each pixel in this image. And you can still see that it's still, definitely see something, even with 6 electrons only to make your contrast.